Today we'll be looking at what we call data manipulation. We'll be looking at data manipulation and data preprocessing. So basically, machine learning is an aspect of Python programming that focuses on developing models that have the ability to mimic or to behave like human beings. That's what machine learning is all about. So, in today's class, we'll start doing some things that are related to machine learning. And the first aspect of things we'll be doing is called data manipulation. So, just like I say machine learning is a branch of Python programming that focuses its attention on something, developing a system that can behave like a human being. It can predict something like human being. It can read from previous data, previous behavior, and then perform a future task similar way to how a human being would do. A practical example of where machine learning are being used is like all these sporty bets and the rest. They usually use machine learning. Another example is all these our Spotify, online purchase systems. You see that at times when you enter, you want to buy something, they will recommend a product for you, and that product might look like what you want. They will recommend a similar product based on your previous search. So all the searches or all the items you've bought before from that store or from that website, they will use those your previous purchases to predict the possible things you will buy in the future. And then using that data, they will be able to come up with machine learning models that can predict how you may likely buy something in the future. So that's a little brief on what machine learning models are. So I'll be sharing my screen now shortly. Okay, I believe you can all see my screen. So I'll be sharing my screen. So the first thing I opened here is an empty Google Colab. So I want to upload the file we'll be working with today from scratch. I just shared two files to the group, so that those are the files we'll be working with. So I'll first of all upload the file. So I'll upload notebook. I'll browse the file. Now, in order for us to do our machine learning properly, Python Python is a programming language that allows you to get help from something that we call a library. Now, what is a library? A library is a book that has pages inside of it whereby, for instance, let me use a layman language to explain. For instance, if you want to write an exam and then your lecturer gave you a textbook, the whole textbook itself, there might be some components within that textbook that you may not need for a particular exam, but there are some pages inside that textbook that you may need for a particular exam. So I can say a library is the entire textbook itself. So whenever you want to solve a problem, a library will allow you to go into itself and then pick out pages that are relevant to the problem you are trying to solve. So Python is a programming language that usually allow you to import libraries. That is like you are trying to import a textbook. You import a textbook and then access relevant pages within those textbook and then use to solve your problem. So machine learning is one branch of Python that you make use of libraries very well. So one of the or the key libraries that we usually use in doing machine learning work, I will mention them. The first one is called NumPy. NumPy is a very important machine learning library that we will use. Another one is called Pandas. Another one is we call Matplotlib. Another one is Seaborn. Another one is Plotly, then sklearn, and TensorFlow. Now, these libraries are libraries that we will use very, very well within our whole journey of machine learning model development. So, NumPy is a library that allow you to perform manipulation on numeric data. That is data that are numbers. NumPy will allow you to perform mathematical operations on them or manipulation on the data. That's what NumPy does. Though as we are using it, you see some of its application. And then one of the most important library we work with, like today, we work very well with is this Pandas. Pandas is a library that allows you to manipulate data in the sense that you can check a data, you can open it, you can close it, you can do all sort of operation on the data. This Pandas library allows you to do that. Matplotlib, Seaborn and Matplotlib, Seaborn and Plotly, we usually use them to visualize, that is to represent data using graphics. If you want to have graphical representation of anything of your data, we usually use Matplotlib or Seaborn or Plotly, any one of your choice. They are all used for data visualization, that is to transform your data into pictures. We use these three. Next, and one of the most important library is this sklearn. We call it sklearn or scikit-learn. The short form of this scikit-learn is what we call sklearn. It is the most important library to build machine learning models, because for you to build machine learning model, this is the library you will use. These ones are for data visualization. These ones are for data manipulation. While for building machine learning models itself, you will use this sklearn. Then this TensorFlow is also for building machine learning models, but TensorFlow is focused only on building deep neural network. There's what we call deep neural networks. Once we get there, we'll all explain that. But this TensorFlow is specifically used for building deep neural network. sklearn is used for building neural networks or normal machine learning models. While Plotly, Seaborn, Matplotlib, we use them for visualization. Pandas and NumPy, we use them for data manipulation, which will be the first aspect of what we'll be looking at today. So, before I go further, I want to believe you are all seeing my screen, right?
Yeah, we are seeing your screen, but I don't know if I'm the only one getting this. The network skipping. I don't know if it's from your end or mine. So I
Yeah,
don't know if others are also
even here,
experiencing
the
same issue.
network is keeping for me today as well. I'm having issues with the network.
Okay. I just hope it's not mine, sha. Okay, I'm coming a minute. Let me switch the network to MTN and see whether. Okay. Can you hear me now?
I believe the network is not really for me because
Okay.
I didn't have instructions since it
Okay.
started.
Okay. Probably it's from the network. All right. So we'll commence now properly. Now, just like I said Python allows you to import libraries, and I said libraries are like textbook that you can use. So today, the first thing we'll be looking at today is data manipulation. How to manipulate data. So, in order for you to manipulate data, now we said what is data manipulation? From what I wrote here, we said in machine learning, data manipulation means changing, adjusting, or preparing data so that it can better suit so that it's better suited for model development. Now, data manipulation has to do with changing the form of your data. Maybe I give you a data and then you want to build a machine learning model that can predict with it. However, the structure of your data doesn't suit a machine learning model. Data manipulation has to do with you changing how the data looks like, because machine learning model, please take note of this point I'm going to say. All machine learning models, whether you are doing natural language processing, predictive models, or anything that's with artificial intelligence or machine learning models do not understand strings. Take note, models do not understand strings. I taught us strings last week. Models understand only numerical values. either integer or float. As long as your data is a string, if you are working with machine learning, if you are doing machine learning, either you convert that string to numbers or you remove it completely. You don't work with it. So take note of that. This point is very important. Whenever you are dealing with machine learning model, any string that is in your data set, you have to do away with it. How do you do away with it? You do away with it in two ways. Either you remove it, that is, you don't make use of it completely, or you change the form. Now, how will you know when you remove and when you have to change the form? I will teach you that as we progress. You remove a data when the data is not categorical. I will repeat my statement. You remove a data when the data is not categorical. What are categorical data? Categorical data are data that they group something into categories. A typical example, gender. Gender, if I should tell you, ask you what's your gender, you can either be a male or a female. These are strings. The spelling MALE is a string. FEMAL is also a string. But in a real sense, they are string, but they are categories. So any data that is a category, you don't remove it. You change the form to numerical data. Today we are going to learn how to change all this type of data to numerical data. But if you have data like JC, Emmanuel, and James, John, all these data, these are not categorical data. These are names of people. This kind of data, you remove them. You remove them. And another key thing you should take note of in machine learning is, if you are dealing with machine learning, any data that will make you to identify somebody, for instance, his name, ID number, all this kind of data. If you are dealing with machine learning, you always remove them from your data. Don't work with them. So whenever you have somebody's name, if I should give you a data set that has somebody's name, a very important step or a good step you can start with is remove that column that has somebody's name. Remove it. You are not supposed to use it. Or if that data set has an ID number, always take note to remove it. You have no business with it. So you only focus your attention on other types of data that are present aside from name or maybe things like state. But for instance, if I should give you a data that is local government, you can classify that one as okay, no, let me say geopolitical zone. You can classify that type of data because we have 8 geopolitical zones in Nigeria, for instance. So those kind of data you can classify them. You can say they are category. But if you have numbers that they are much like names, what you did today, something like that, all those data, any data that doesn't group people, do away with it. Another typical example of categorical data is your class. Maybe somebody's in JS1, JS2, JS3, SS1, SS2, SS3. These are categorical data. I gave example of gender. If I should say something is yes or no, this type of data, all they are categories. So if you are dealing with machine learning, those type of data, if they come in string format, you need to change them to numeric format. So that's the first key point I want to highlight before we proceed. So data manipulation has to do with changing all these data, changing their form. So that is what data manipulation is all about. So back to these libraries that I mentioned here. In order for you to do data manipulation, I said data manipulation, we usually use two key important libraries, which are NumPy and Pandas. Now, how do you use them? In order for you to use them, the first step you have to do, as long as it's Python related, the first step you have to do is you need to import. For you to use a library, you must import it. I will repeat, for you to use a library, you must import it. So the first thing is for you to import pandas and also import NumPy. I said we are using two of them. You need to import both of them. You need to import both libraries. So you can see import pandas, import NumPy. You can start with import NumPy before you import pandas. It doesn't matter. But then another thing again, this pandas is long, and whenever I want to write it, I will be writing pandas in full. So there's a way you can replace it with something, just like the way we are creating variable. We say you can create a variable to represent something. Here too, you can represent imported libraries using some little keywords. So these pandas, I can say import pandas as PD. What it means that anytime I want to call pandas, I don't need to go and be writing pandas. If I just write PD, it knows I'm making reference to pandas. Then numpy also, I can say import numpy as NP. So anytime I want to import numpy, I don't need to be writing numpy. I'll just write NP. It knows I'm making reference to numpy. So that's the first step. The first step in machine learning or data manipulation, anything you have to do is to import your libraries. These are my two libraries that we'll be using in this work. I just imported them. And mind you, I said I imported pandas as PD. What it means is anytime I want to call pandas, I will not be writing pandas. I'll just write PD. It knows I'm making reference to pandas. And anytime I want to write numpy, I imported it as NP. So the moment I write NP, it knows I'm making reference to numpy. So I will run that. Okay, let it connect. But I believe what I have said so far is clear, right? Any
Yes, sir.
questions so far? Okay, I believe there's no question. All right, so let's proceed. So step one, please, you can be writing these things I'm saying maybe somewhere in any machine learning work, maybe in a booklet, something like that. I said the first step is to import the libraries you'll be working with. And for data manipulation, we said the two most important library for now, for today, we'll be looking at is pandas and numpy. And then I taught you how to import. Then you write import pandas. But because pandas is a little bit long, I don't want to be writing pandas anytime I want to use it. I'll just write PD. So PD, any place I want to call pandas, if I just write PD, it knows I'm making reference to pandas. NumPy, the same thing. If I write NP, it knows I'm making reference to NumPy. So I don't need to start writing it afresh. Now, the next thing you have to work with is your data. Please, minute, please. Okay. So the next thing you will need that is very important is data. Just like I said machine learning models, they learn from data. So there's no how you can build a machine learning model without data. There's no how you can build machine learning models without data. They need data. Although we have two classes of machine learning model, we have supervised learning and we have unsupervised learning. But for the sake of this course, we'll focus our attention on supervised learning. Supervised learning is what we'll be doing. Unsupervised learning is an advanced class and is not, if I should bring that into what we are doing, it's a different ball game entirely of its own. So our attention for now will focus it on supervised learning. So for the whole of this 2 months course we'll be doing, we'll be focusing our attention just on supervised learning. So supervised learning. Now, what makes a data to be a supervised learning? A data is a supervised learning, or machine learning work we are doing is called supervised learning if what you want to predict is inside the data set. If what you want to predict is inside the data set, like this data I open. Now, this is a data set of some individuals. The data set have the height of people, their gender, and then their shoe size. Their height, their gender, and then their shoe size. Now, you ask, gender of people, sex number stands for gender. Now you'll be surprised, why are you seeing 2, 2, 2, 2, 1, 1, 1 instead of normal gender, maybe male, female? Why are you seeing something like this? The reason is because this data set, the person that gave us this data set has already processed the data. He has performed data manipulation on the data set, but he hasn't finished. Although he finished it, I created some issues within the data set because I want us to handle it today. So this height, that's the height of a person. Then this one is the gender of the person. I will explain what these two ones stands for as we process, as we proceed. And then these ones are the shoe size of the people. So we are trying to, one of the work we'll be doing in this course is we'll build a machine learning model that can ask somebody to just tell you his gender. Sorry, his height. The moment the person tells you his height, you will be able to predict the shoe size of the person without you asking the person. Just from his height, you can use his height to know his shoe size. So that is what we use this data to do. Not today actually as we progress, but today I want us to start with performing manipulation on the data itself. So this is the data we will use, and I just share this data with you in the group. So for you to work with the data in your Google Colab environment, you need to import it. You need to upload the data. So to upload the data, you don't import it the way you usually import libraries. No, you upload. How do you upload? The way you can upload it. So please take note of these next two lines. Next line, sorry. Take note of this. Sorry, let me delete this. This is not part of what we do. So take note of these next three lines here. If you want to import your data in Google Colab, please, you have to do these three steps. Step one, you need to write this from google.colab import files. That's step one. From google.colab import files, then you run it. That's the first step. Now, the second step will be you have to write files.upload. File.upload will allow you to access your system. It will allow you to access your system. So you can see it created something like this, choose file. So I'll click on it. If you go to the folder where your data is saved, that data set, that's that data file that I sent to you, or any work that I give you, I will give you a data too for your assignment. So whatever folder you save that data, you go to that place. Me, I saved it inside this data folder. This is my data. So you upload it, you click on it, and then click on open. The moment you are done, allow it to upload. You see, the moment it shows this check, it means it has finished uploading. Once it finished uploading, in order for you to upload it and use it in your file, now check. This is the name of the data. Whenever you upload it, show you the name of the data here. This is the name of the data. Data.csv. That's the name of the file. Or if you click here, you can see the data. This is the data here. So all you do is you click here and then go to copy part. Copy the part. After you've copied the part, now you need to create a variable that will represent this data. Anytime you want to work with this data, you don't need to go and be clicking it, opening it, clicking it. It will not even work. It will be giving you an issue. So you need to create a variable that will hold that data set for you. Data, we call it data set. So you need to create a variable that will hold the data set. So I called the name of my variable in this work, I call it data equal to. Now, if you check, what is the name of this file? The name of this file is data.csv. Now, CSV is a comma separated file. We have different types of data. We have Excel file. Excel file, their extension is Excel file, the extension is .xlsx, something like this. This is the extension of Excel file. We have .html file. We have .txt file. We have .pdf. That's your normal PDF. We have .png. These are different .jpeg. These are different file extensions, and we have .csv also. CSV and this Excel file, you can open them using Microsoft Excel. That was why I was able to open the data in my Microsoft Excel environment. So this is a CSV file. How can you open it using Pandas? Pandas can allow you to open the file. So how do you open the file? The first thing you have to write is to write your pandas. Remember, I said pandas, we call it PD. So you say PD dot. Now, remember I told you a library is like a book, and then it allows you to access a page. So if you write the name of the book, in our case is pandas. This dot means I want to access a particular page. Then you write the name of the page you want to access. Now, how can you read this file? The name of the page in pandas that allows you to read any data given to you called read, then the extension of the file. If it's an Excel file, you write read Excel, bracket, open, close. Then inside here, you write that copy to part. I've copied something from part. I'll just put comma and then I paste what I've copied. This part that I copied means location of this file inside my Google Colab. That is what it means. So if it is an Excel file, we say pd.read Excel. Now, any type of file, if it is a .html file, you are to say read HTML. If it is a TXT file, you say read TXT. If it is a JSON file are data that looks like dictionary. They are separated by that curly bracket, this curly bracket. Those are the type of data we call JSON file. If it is that one, you say read JSON. This is how pandas allow you to read different. So all these read JSON, read TXT, read HTML, read Excel, all of them they are pages inside pandas. So in order for you to access them, take note, always write PD first, dot before the page name. So in this our case, this data we are trying to read, what is the extension? And for you to know the kind of the page you are to access is from the extension of the file. This file is data.csv. So our extension is .csv. I have to say pd.read CSV. Then open and close bracket. Then remember I said you click here copy part. So that part that you have copied, you put your your quotation mark and then you paste that part that you've copied. That's all. Then you run it. You can see my data has run. So let me show you that the data has been imported. Remember your variable is called data. So anytime you want to access this data set, you just write data since you've given it a variable name. So if I should write data and run, you can see this is the data set. Exactly the way it is in my Excel file. Let me split it so that you can see it properly. Now you can see there's no difference. You can see the only difference is that this one give this first column. This column does not have a name. This column stands for index. It's not even important. So as we are proceeding, I'll show you how to remove it. We are going to remove it. It has no use. So that's the only difference. But if you check, the first one is 0162 4.0. You can see 0162 4.0. Now, forget about the .00.00. Remember, 0 and 2 are the same thing. The only difference is that one is a float, one is an integer. So it's the same thing. This one is seeing everything as an integer. This one was representing them as float. But aside that, you can see that everything is the same. Check the last value. The last value is 63,152,239. Let's go to the last value. You can see 63,152,239. So you can see that the exact data set has been imported. So this is not an Excel environment, but you can import your data. So first step, I said the first step whenever you are doing data manipulation or you are trying to do machine learning, your first step is importing your necessary libraries, which in our case, we imported NumPy and we imported pandas. Now, one good thing with machine learning is that all these steps I'm going to call, they are repeated. So today, what we do today, tomorrow if we come back is the same step we'll follow again. The only difference is in the data processing. It might differ, but they are almost the same sequence. So please always write it down. If you have your book, you can be jotting all these key points I'm saying. So we've imported our libraries. That was step one. Step two is importing your data. That is what we did here. I showed you how to connect your Google Colab to your system. I showed you how to upload, how to have access to your browser, your system browser to upload data. And then I showed you after you've uploaded the data, how can you read it? I told you if it is an Excel file, how do you know it's an Excel file? I said the extension will be .xlxx like this. This is the extension. If you see any file that have extension like this, it means it's an Excel file. So here will not be read CSV, rather it will be read Excel. But aside that, any other one, if it is .html, you write read HTML. If it is .txt, you say read txt. If it is .json, you say read JSON. So that is how we read different file formats. So I believe my explanation are clear, right? Any questions so far or confusion? Is there any confusion or anyone with question?
Well understood, sir.
All right. All right. Thank you. So let's proceed. Right? So let's start our data manipulation properly now. The first thing we did was we imported the data that we are going to work with. So I believe now if I should give you data, you can import it in your Google Colab environment. So step 2 is called data exploration. Now we have two types of data exploration. You can write that down. We have two types of data exploration. We have statistical data exploration and we have visualization. Visualization is 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 basically visualizing or representing your data in pictorial format. Now, that is where a data analyst, the knowledge of a data analyst stop. The knowledge of a data analyst begins from importing libraries, importing the data, performing statistical visualization, statistical exploration, and then visualization. That is where a data analyst stops. But you, as a data scientist, you go beyond that. After exploring the data, you can process it, you can build machine learning model, you can do other manipulations. You are more than a data analyst. So I said we have two types of data exploration. We have statistical and we have visualization. For today, we are not looking at visualization. We'll be looking at visualization in our next class. That's when we'll be looking at visualization. But for today, we'll be looking at statistical data exploration. Now, what is the statistical data exploration? Statistical data exploration is a method of exploration whereby you try to see insights on the data. When we say insight, that is, you are trying to explore the data, you want to understand what are the different things that are inside the data. However, you are not representing it in picture. You didn't do any pictorial representation. That's what we call statistical. So one statistical data exploration is data.head. Now, what is data.head? Now, let me show you something here. Let me show you something in the previous place. Okay, now when I get this variable data, look at something. Unlike when I showed you in Excel, when I showed you Excel showed you the entire data set, but this one didn't show you the entire data set. If you notice, it showed you from 0 to 4, and then it put dot 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 dot, then it showed you from 159 to the last one. Now, these first five data points. Now, this is row 1, row 2, row 3, row 4, row 5. That is what we call head of a data. Head of a data is simply means displaying the first 5 entries within the data. So at times, whenever you are uploading a data set, it is not, you cannot view everything within your Google Colab environment or any machine learning work. You cannot view everything unless the data set is very little. Like maybe it has 5 columns or 10, you can see it all. But if you are doing real machine learning work, you might have even a million data columns. You might have a million rows of data. If I say rows, that is this 0, 1, 2, 3, 4, 5. They are the number. Remember when we were doing list, I told you indexing starts from 0. So the same thing applies in machine learning. That is why you are seeing 0 instead of 1. This is the index. These are index of each row. These are index of each row. So indexing starts from 0. So if you are trying to access a data set, you want to see the content. The way machine learning is structured, it will only show you the head, that is the first 5, and the last 5. So this first 5, we call it head of the data. And then this last 5, we call it tail of the data. Head and tail. So if you want to explore, one exploration you can do is to just see the first 5. In order for you to see the first 5, you tell it, I want to see, you say, I want to see the head of my data. So if you say data.head, you are telling it, I want to see just the head. So it's going to bring only the first 5. You can see what it printed out here is different from what it was here. Here it printed the first 5 and the last 5, but you can see here it printed only the first 5. So that is how you access the head. So from my little explanation, since I told you first 5 is head, last 5 is tail, it's trying to tell you that if you want to print the last 5, you say data dot. So you can see it printed the last 5. You can see the index. You can see that was where this last one started, 157. So you can see it was the same thing it printed here. So that is one data exploration you can do. You can see the first 5 column and you can see the last 5. So at times, if you are working with data set, you might not want to, you want to make your code to be clean, you want your work to be short, precise. You can just print either the head or the tail. It's up to you. Except if maybe your the person that gave you the work will tell you, I want to see the head and I want to see the first five and the last five. Then you can print the head or the tail depending on the requirements of the person. So that is one data exploration. The second data exploration is info. Now, whenever I write data.info, what it means, info is the short form of information. Now, what does information tells you? Information tells you how many rows are in your data, what are the different columns that in your data, what are their data types, and also are the data having missing values or not. Now, what are missing value? Let me show you a practical example of missing value. Let me open the data back in Excel. I created some missing values in the data set because I want us to handle it. Let me show you. This is a practical example of a missing value where there is no data is missing. Now look at, I gave you the gender of the person, I gave you his shoe size, but I didn't give you his height. It's a missing value. Another missing value, look at another missing value. 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 So all these things, if you are working with machine learning model, if you didn't remove these missing values, if you didn't handle them, your model will never be developed. It will raise an error for you. So when you are working with machine learning model, you need to handle all these missing values. So this data.info will tell you whether there are missing values in your data. How do you know that there is a missing value? You will know that a column has a missing value if the number of not null in machine learning. Null, whenever you hear null means missing value. Null or none. Whenever you see null or none, what it means is missing value. Whenever you see none, it's trying to tell you, or null, it's trying to tell you that this place is a missing value. This is a practical example. This none that you are seeing is trying to tell you there's a missing value here. Let's check again. Okay, here there's no missing value, but here there's a missing value. Other missing value are within this they are hidden, but we'll check them to see. So the .info will help you to know how many whether a column has a missing value. So now when I did data.info, you can see that it brought out some information. So now let's calculate. How do I know how many rows? Now, if I should say how many data points, if I say data point, what I'm trying to say is how many rows are in your data. That is how many? One. Something like this is what we call row. This is what we call row. This is row 1. This is row 2. This is row 3, like that. So the number of rows will tell you the number of data that you have. Mind you, the number of rows will tell you the number of data that you have, and that is very important. Fewer number of rows means you have a small data set, and if you are trying to build a machine learning model with small data sets, it might result to a problem. It might cause a problem for you. So it is very important to know how many rows or how many data points you have. So if I should print data.info, how do you know the number of rows? This is where you will know the number of rows you have. You can see say 162 entities. What it means is you have 162 entries or rows in your data. And if you check, the last index here is 161. Remember, our indexing starts from 0. So from 0 to 161 is 162. That is why you are seeing 162 entities. It's trying to tell you that the number of data points, or the number of rows you have in this data set is 162. So that is one important information that this .info can give you. That is an important information that this .info can give you. So it told us that our data point has 162 rows, and it went further to tell you the rows start from index 0 and stops at index 161. That is what this line is trying to explain. You have 162 data points starting from index 0 to 161. I believe this point is very clear. Furthermore, it tells you how many columns you have. You have a total of 4 columns. What are the columns? Unnamed column 0, which is this one that I showed you, this row. Although I told you it's not important, it's because we have not removed it. That is why it's showing there. When we remove, you see that the number of columns will reduce. So since it doesn't have a name, that is why our data set said unnamed. That is, it doesn't have a name. Any column that doesn't have a name, this is how pandas represents it. It will do unnamed dot dot zero. If there is another one, maybe you have one column here unnamed, and then you have another column before. Let me do something like this. Let's say you have this one, you have this one. So what pandas will do is to call this one unnamed dot dot zero, and then to call this one unnamed dot dot one. So that is how pandas works. So because that column doesn't have a name, that is why you are seeing this. So it told us we have 4 columns, and these are the names of the columns. You can see this column is telling you the names of the column. Now, what does this 0, 1, 2, 3 means? It's telling you that this column, these are their index. Remember, these rows, they have their index. This column to have their index. So if you are trying to read your data row wise, this is index 0, this is index 1, this is index 2, like that, like that. Then if you are trying to read it column wise, this is index 0, this is index 1, this is index 2, this is index 3. So if I should ask you, what is the index number of height, column height? The index number of column height is index 1. The index number of sex number is column 2. The index number of shoe size is column 3. So rows have their index, column also have their index. So that is very, very important in machine learning. You can access data column wise using their index. You can access data row wise using their index also. So this .info is telling you that these are the names of the columns you have, and then these are their index. So unnamed 0 is at index 0, height is at index 1, sex number is at index 2, and then shoe size is at index 3. So now here, this 162 not null. Remember, I said not null means values that are not missing. Null means missing values. So this 162 means it's trying to tell you unnamed 0 column, that is this first column, has 162 entities. Has 162 entities that are not missing values. So if you check, how do you know that it doesn't? If you want to be sure that it doesn't have a missing value, the number of not null that your info will pick will be equal to the number of total entities. Remember, our total entities in 162. So they told us that not null has 162 not null. It means this unnamed index 0 has no missing value. It doesn't have any missing value. That's what it means. Why? Because 162 is equal to 162 here. Now let's check height. Height was 158 not null. Check 158 not null is not equal to 162 entities. It's not the same. It means it has about 4 missing values, because the 162 minus 158 is 4. It means height has 4 missing values. So if you didn't handle those missing values, if you are trying to build a machine learning model, there will be a problem because of those missing values. X number has 160 not null. It's not 162. So it means it has 2 missing values. Shoe size has 160 not null also. It's not 162. So it has 2 missing values. So overall, you can see that it is only this unnamed that has 162. And remember, this unnamed is not even important for us. It's not important. I told you as we progress further, we'll remove it. So this 162 that we are seeing here, this is the only column that has no missing value. However, it is not too important. So our important columns, which are the height, sex number, and shoes, all of them, they have missing value. Why? Because their total number of not null is equal to the total number of entities. And then these are the data type. Remember, I taught you data type. Now this 64, forget about these numbers. The important is to focus on what the data type is. If you can see, this unnamed is a number. You can see the data type is int. The other height, sex number, and shoe size, it all categorize them as floats, because when we tried interpreting it, you can see it added dot, 0.0, 0.0, 0.0. So all of them, they are floats, they are decimal numbers. I told you any number that have dot something is a decimal number. So that is why it identified them as float. So I think this our time is almost up. So immediately the meeting exits us, we'll proceed to the second link that I shared in the group, and then we'll continue with that. So before it exits us, I will stop here and then give room. Is there any question so far? Is my explanation clear and well understood? At least when you click, if you write data.info, I believe you can understand what the info is all about. If there is any confusion or any clarity you need, you can ask. Okay, I think Emmanuel is raising his hand, so maybe you can ask your question.
Okay. Yeah.
Ni Ghana
My
ba
own
ni wa-
question is actually in the previous, Sha. All your explanation, I kind of understood the Sha, but about this panda you've been mentioning, like I want to understand, like, did we like the panda? Did you install it the way you installed the Python the other day, or
No, 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 no,
is
no.
there a way?
That is why I
Okay.
said it's good for you to use Google Colab. Google Colab have them already. Your own is just to import. You don't install.
Okay.
But there's a
Okay.
way you can install it. Let me show you how you can install it. You can install it using a command called pip install pandas,
And
because there are some libraries like Plotly that I explained, that I showed you earlier, except for visualization. Google Colab doesn't have it. So once you want to start using it to install it, this is how you install.
okay.
But if I should run it now, you are going to see that it will tell you requirement already satisfied.
Okay. Okay. Okay.
Requirement already satisfied is because it already has it installed.
Okay.
You understand? So
Yeah.
that was why I just went ahead to start importing it without
Okay.
anything.
All right.
Okay. Any other question? I think that's me. Make I this. Why not the charger handle? You know the handle. Any other question? Okay. I believe others are here. So let's proceed. So we are still on data exploration. Another type of data exploration is correlation. Now, what is correlation? Correlation is a data exploration that tries to check the relationship. If we say correlate means how close are they with each other, or proportional. That's what correlation is all about. Now, we have two types of correlation. We have positive correlation and we have negative correlation. When I say positive correlation means if one value is increasing, it can affect the other one in such a way that the other one too will increase. If two of them are going in the same direction, we say they are positively correlated. And then if two of them are going opposite direction, that is, if one is increasing, one is reducing, that's negative correlation. Please take note of that, because it's very important when you are trying to build your machine learning models. So how do you check the correlation of a data? To check the correlation of a data, you say data dot CORR, open and close. Remember, any function, these things, anything that has open and close is called a function. Remember, I taught us function the other time, but functions, these functions, you can pass them without any parameter, or you can pass them with a parameter. Some of them have parameter, but parameters, functions like all these info, they don't have a parameter, so you can just pass them empty like that. So this dot correlation, we try to check how related are your data points. So how does it do that? It does that by visualizing all the columns you have on the vertical axis and on the horizontal axis, and then it will check them. Now, if you see, correlation is always between 0 to 1, or sorry, it's between -1 to 1, -1 to 1. That is what correlation is all about, -1 to 1. So if the closer a correlation value is to -1, the more negative it is. The closer a correlation is to +1, remember, if I should just write normal one means +1. The closer it is to +1, it indicates positive correlation. Closer to +1 means positive correlation. Then being far away or closer to -1 means it is more negatively correlated. So it will map, in order for you to check the correlation, it will map them together. So first of all, it will put all the columns horizontal and then do them vertical also. And then it will check how is unnamed 0 correlated with unnamed 0. It will do it like this against this, like this against this, like this against this, like this against this. It will finish before it will go to this and this, this and this and this and this. It will do until it finishes. Now, a column is always positively correlated to itself. That is why you see 1. Unnamed 0 and unnamed 0, the correlation is 1 because it's the same column. So it has to be highly positively correlated. That is why you see 1. Now, unnamed 0 and height. Okay, let's even forget about the analysis of this unnamed 0 because we are going to remove it. It has no work. It has no use in our data set. So let me start from height. Height and height. If you do it like this and then you do it like this, you can see that height and height is 1. The reason is 1 because height and height is the same. So it has a positive correlation. If you check height and gender, you can see the correlation is minus 0.2. So what it means is height and gender is negatively correlated. What it implies is the higher your height. Now remember, you might be confused. You say, I'm saying the higher your height. Height cannot be higher or lower. But remember, in our data set, our height are represented as numbers. 0, 1, 2, like that, like that. I'm going to show you the different category. I want to explain this correlation first. The reason why I said they are represented as 1 and 2 is because I said the person that I got, the place where we got this data from, the data has been processed. The data has been processed for machine learning work. That is why. Instead of letters, you are seeing numbers. So the reason why it's showing minus 0.2 is that the higher the height, the lower your gender. Or the lower your gender, the higher the height. Remember, I told you negative correlation means they are going opposite direction. So if you check height and shoe size, it has 0.6. 0.6 is closer to 1. It means it has a positive correlation. It means the higher your height, the higher your shoe size. And that one is true. Normally, taller people have more shoe size. Their shoe size is bigger than shorter people. Their shoe size. People that are more tall, they have more, their shoe size is higher than those that are short. So that is what is height. Now, the same thing, gender and height, you can see negative correlation. So it is this same value that will be repeated here because it's as if the thing just turned upside down. So you can see gender to itself, you can see it's 1, and then gender and shoe size has a negative correlation. What it means is the higher the gender, the lower the shoe size. Now, mostly women have smaller shoe size. That is to say, the higher gender in this data set, the higher gender that is in our data set, I think the Caesar set has gender 1 and 2. 1 stands for male, 2 stands for female. That is what the data set represented those data for. 1 stands for male, 2 stands for female. So if you check, you see female has the higher number. And mostly female have smaller shoe size than male. Females, they have smaller shoe size. So that is what this gender is trying to tell us. You see negative correlation. So it's trying to say that the higher the gender, that is the higher the number, 2 is bigger than 1. So the higher the number, the smaller the shoe size. That is what this negative correlation is. So that is what correlation tries to show you. Correlation tries to show you how related those data points are with each other. It tries to show you how they are related. So that is that on correlation. The next data exploration we are going to do is data.shape. Now, mind you, someone will ask, okay, and when we're doing correlation, we're doing info, we are usually put open and close bracket. But why is it I didn't put it in shape? Shape is the same function to is also used for data exploration, but shape is the only function that doesn't use open and close. It doesn't use open and close. So please take note of that. It is a function or it is a page inside your pandas that you can use for data manipulation, but it doesn't have open and close. So what does dot shape do? Dot shape tries to show you how many rows and how many columns you have. So it takes its information from this same place here. It picks its information from this same place here. Remember, 162 columns. This is it, 162 columns. And then it says our data has 4 columns. Sorry, 162 rows, and it says our data has 4 columns. This is the 4. So this is row, comma, column. That is what dot shape does. Dot shape will tell you how many rows you have in your data set and how many columns you have in your data set. So that is that on data exploration. The next thing we'll start now is data pre-processing. Next thing we'll start is data pre-processing. So what is data pre-processing? Data pre-processing, now data manipulation is specifically all about data pre-processing. So you can call it data pre-processing or you can call it data manipulation. Now data pre-processing has to do with you trying to change or ensuring your data is in the suitable form that can fit into your machine learning model. So one data pre-processing you have to do in your data set is removing any column that is not important. Removing any column that is not important. So if you remember earlier, I told you this unnamed dot zero column is not important. Now, please, whenever you are trying to do some manipulation on your data set, it is always important to copy the name of the column exactly the way it is. Copy it. At times, if you want to type it out, you might make mistake. But if you understand the name very well, you can type if you are fast like that. But like this type of column, because at times just this space that is in between, if you didn't put it, it will raise an error for you. So at times, if you didn't copy those spaces, these white spaces, we call them white space or gap. If you didn't copy these white spaces exactly, it will raise an error for you. So at times to avoid issues, except if you have columns that have a single names like this without any white space, you can type them out. But these ones that have white spaces, it is very good. It will be a good practice for you to just highlight it, right click, and then copy. Or you highlight and then click on Control C to copy it. So one important data pre-processing you can do is to remove any column that is not important. How do you remove a column that is not important? To remove a column, you call the name of your data set and then put dot and then you put drop. Open and close bracket. Within your bracket, you write the name of that column that you want to drop. That is the column that is not important and you want to remove. So in our case, I've copied the name of the column. Now, what is this data? This data that you write here is you are trying to tell me, I want to remove this column from this data set. That is what it implies. I want to remove this column from this data set. So data set dot drop. So whenever you want to remove something, you always use dot drop. So dot drop is a function that helps you to remove something from a data set. So I'll say dot drop. Now you pass list, you create a list, an empty list, and then write the name of you paste the name of that column that you want to remove. Now, why did I say create a list? Because at times you may want to remove more than one column in your data set. At times you may want to remove more than one column in your data set. Let's assume I want to remove this height also. I will pass it here. You can see these are lists of columns that you want to remove, but we are not removing height. I'm just showing an example. So it is only one column that I want to remove. So you can see that's the same thing I did here. And then now this is the first step. The next thing you have to do here, you have to put comma and then put something called axis. Now what is axis? Axis means what direction do you want to remove. If you didn't put this axis, it will not be removed. It will assume that your axis is 0. Now we have two axes. We have 0 and 1. These are the two axes we have. 0 stands for row, that is these rows like this. These rows like this from left to right. That is axis 0. And then axis 1 means column wise. That is like this from up to down, up to down, up to down, up to down. That is what we call axis 1. So please take note. Index 0, axis 0 stands for row, axis 1 stands for column. So if you check this unnamed 0 is a column. is a column, not a row. So you must specify your axis, axis 1. If you didn't put axis and you just run it, you assume that the axis is 0. So what it's going to do is it will go and be checking on name 0 in the column. It's trying to check whether these numbers here, any of them, is on name 0. It will raise an error because these numbers here are just indexed from 0 to 161. There's nothing like on name 0. You can only see on name 0 on the column. It's the name of a column. So you have to specify that my axis is 1. If not, it will try accessing it from the row and it will raise an error. So let's do that practically and see. You can see it highlighted red. It's trying to tell me there's a problem. You can see not found in axis because it tried accessing axis 0 and it can't find it. But the moment I put it, I change it rather to axis 1, I specify the axis. Axis equal to 1. If I should run it now, you see there won't be any error. You can see it run. And you can see that column went away. That column went away. So you can see that your new data set now doesn't have that column. But there's a problem. Okay. I think Ima is raising his hand. All right, you have a question, I think. You can ask your question. You can go ahead and ask your question.
Can you guys hear me?
Yeah.
Can you guys hear me?
Yes, I can hear you.
Okay. About the axis bar, you said if it's axis 1, it's talking about the column bar. If it's 0, it's talking about the row.
Yeah.
Okay, like let's assume now. Okay, wants to remove the maybe is a row you want to remove. Like how are you supposed to put? How are you supposed to do it?
If you are trying to remove a row, though there's an example down that we are going to do that will show you how to remove row. But if you are trying to remove a row, let me show you. Like let's say I want to remove this row 0 and this row 1 bar. Let's assume I want to remove. So you pass. Remember, I told you this list collects all the things that you want to remove. So I said I want to remove. Okay, let me remove row 0, 1, 2. So I'll pass the index 0, index 1, index 2. I've passed them to the list. So my axis now will be what? 0.
Axis 0.
See, they will be there.
Okay.
Clear, bro? So this is how you remove row wise. So if you are trying to remove through row, you use index. If you are trying to remove through column, you use the name of the column.
Okay.
So it's clear, and mind you, your axis is very important.
Yeah.
Row axis 0, then column axis 1.
Axis 1. All right.
Clear,
Yeah, it's very clear.
All right. I had a sound. I thought someone raised his hand again. Is there anyone with any question again? But I believe my explanations are clear, no confusion.
Yes, it's clear.
All right. Thank you. So let's proceed. I'm surprised this meeting today didn't log us out. All right. So let's continue. Okay, back to what we are doing. Okay, Owen, you can ask your question.
Okay, yeah. Sorry if I'm trying to draw us back a little.
Okay.
When you remove that column, Abi, the 0 stands for It was 0 we removed or 1 when we were removing that.
No, if you are trying to remove the name of a column, your axis must be 1.
Okay, so what I'm
if you are
trying to say now,
so the axis is 0. Okay.
After removing that particular column unnamed.
Yes. Yes.
That's okay. So that particular serial number that is counting from 0 to 1 is static.
Yes, this one are the number. Now
alignment.
They are the index of each row.
Okay.
Index of each row.
So,
but these ones are the names of each column. But they too, these columns, they have their index. So as I removed, remember initially I told you this name 0 is the one at index 0, like we did here in our info. It showed us. But now that we removed it, height is the one now that is occupying index 0. Let's check that. Let's
Okay.
check that and see. Let's check it. Let's say data.info, data.info.
Mm.
I made a mistake. You see that okay, sorry. Yeah. It will not reflect because there's something here. I've not finished what I'm trying to say here. Now, if you see the whole of this thing, if I run it back, see unnamed 0 has been removed. But
Mm.
if I should put data, you see that it will still be there. If I put data, it will still be there. Can you see? Now, what is the reason? The reason is because
Okay.
I have not passed this whole thing that I did to a variable. Remember that data that we have been working with is a variable. So
Mm.
I need to
Mm.
replace
Data,
its
yeah.
previous value. So I will say data.
Mm.
Then that thing that I wrote here that I just cut, I will paste it back.
Mm.
If I should run it now, it will go and
Okay.
replace the previous data. So now let's type data. You see that unnamed column is gone. Can you see? It's gone now.
Okay. Okay.
So it's clever. So now let's check the info
Mm.
again. Let's check the info again. Let's run this info. You can see height 0 now is the one occupying index 0. You can see the total number of columns now have reduced from 4 to 3. So I believe everyone, my explanation is clear, right?
Yes, yes, very
Okay.
clear.
So Owen, have I cleared your issue? Because I'm seeing your
Yes.
hand is still
Yes,
up.
you have.
Okay.
Yes. Okay. Don't mind.
All right.
Yes, you have cleared my issue.
All right.
So the row now, to remove row now, is by the row's number.
Yes. Yes. The
Then the column
index.
is the name. The
Yes. The
index
name.
number. Then the column is the
Is
name.
the name. But please
Noted.
take note. The axis is very important. Axis number.
Mm.
Uh-huh. So
Mm.
now
Zero
this
for row, then one for
yeah,
column.
then one for column. So mind you, whatever thing you are doing after the end, pass it to a variable. That's the variable of your data set so that the data set will be updated. Please take note of that. Now there's another way. Maybe let's assume you don't want to use the variable here. You don't want to use this variable name here. Another way you can do that is after this axis, put in place equal to true. The moment you put in place equal to true and run it, it will replace. Now the reason why it raised this error is because I have removed it already. So let me restart my code from up, and then once we get there you see that it will. Now, okay. Aha. So now I didn't pass this data to any variable, right? I said I want it to auto update my data set without me passing it to a variable. To auto update it, you put this in place equal to true. But mind you, if you put in place equal to true, you can only run it once. If you run it for the second time, it will raise an error for you. You can only run it once. If you want to rerun your code afresh, you have to restart everything. You come to this run time, and then you come to this restart session and run all. So you have to restart everything from beginning. If not, if you rerun this place more than once, it will raise an error for you. So I'm going to run it once now, and you see that my data set will be updated without me passing data to any variable. So let's run it. You can see it has passed. So let's just check the data now. Unlike before, that the unnamed column is still showing, you can see now it has been removed. So I've showed you two ways. You can either pass this dot drop data dot drop unnamed as is equal to 1 to a variable, or if you want to do it direct, pass it and then give it an in place equal to true. But mind you, in place equal to true works only once. So that is how to drop. So we are doing data pre-processing now. Remember, we said data manipulation is getting your data set ready for machine learning model. So you remove anything that is not important. You do away with them. Now, the next data manipulation that I want, data pre-processing that I want us to do is, we will check how many missing values are in each column. How many missing values are in each column? before we remove them. So how do you check? To check, you say data dot is null means check which one is missing value. Which one is a missing value? Remember, I told you null or none is missing value. So to check whether something is a missing value, you say dot is null. Then to know the total number of missing value in each column, you add dot sum. Dot sum means calculate the total number of missing value in each row. Then you run it. To bring out all your each column, sorry. So to bring out all your columns, you can see it told us my height column has 4 missing value. Let me make it better. You can see my height has 4 missing values, my gender has 2 missing values, my shoe size has 2 missing values. If you remember earlier when we did this dot info, that was, I told you the same thing. I said if you subtract 158 from 160, you will get 4. That is the number of missing value. If you subtract 160 from 160, you get 2. The same thing here too. So you can see that's the same thing. So now using this dot is not dot sum. It's very important. If you have plenty columns, you can't go and be calculating it one after the other. The reason why I'm able to calculate my own manual is because the data set is small. So what if you have a larger data set? If you have a larger data set, you can't be calculating it like that. So what you need to do, you will use this to see the total number of missing value. So missing value, remember I told you missing value can affect your data. Missing value can affect your data. So you need to handle them. There are two ways of handling them. To handle a missing value, you can handle a missing value by filling it or by removing it. By filling it or by removing it. Let me do a copy of my data set. Let me say data set 2 should be equal to data. Now, I just did a duplicate of my data set. I want to show you guys something. I just did a duplicate of my data set. Data 2 is the same thing as data. Let's run it and see. You see that it's the same thing with the data that we've been working with. So I want to show you how to manipulate using replacing missing value. Now, how do you replace missing value? Any place that is missing in the data set, I call the copy data set, I call it data 2. So to fill in a missing value, you can say fill now. Fill now is used to fill a missing value. Fill now is used to fill a missing value. So how do you fill it? Now, one way you can fill it is you can fill it by finding the average, that is the mean of each row. That is, missing values that are in height column, I want to replace them by finding the average, by using the average height. Missing value that is in gender, I want to replace it by using the average gender. Missing value that is in shoe size, I want to replace it by using the average. How do you do that? In order for you to do that, you will call the name of the data set, which is this duplicate is what I'm using now. So the name of the data set is data set 2. I will say data set 2 dot mean. Data set 2 dot mean. And then comma in place. Remember I told you whenever you put in place will auto update your data set. So if I should, okay, now before I run it, let's check something. Here we did a duplicate. Let's say data 2 dot is null dot sum. We want to check whether it has missing value. Now you can see it has missing value, right? Height has 4, gender has 2, shoe size has 2. Okay, now let's run this cell and then let's go back and run that code again. Now we've replaced our missing values, right? Now let's copy this code and rerun it again. Then let's see whether there will be missing values now. Now you can see the missing value has disappeared. None of them has missing value. Let's check the info. Data2.info. You will see that all of them has 1:1:1. Why? Because we have replaced the missing value with the average in each column. So that is one way you can handle missing value. You can handle missing value by replacing the missing values in each row. You can use average or you can use the maximum number. To use the maximum number, you say max. Or you can use the minimum number, you say min. Or if you have a specific value in mind, let's say I want to fill it with 0, you can say fill that missing value with 0. Or if you want to fill it with 1, you can say fill that missing value with 1. But mind you, any number you put here, it will put it in all the missing values that are in the entire data set. But if you put data2.min, it's not going to use one value to replace all the missing value. It's going to calculate for each column. So it will go to height column, all the missing values that are in height column, it will replace them by the average height. If you finish it, you go to gender, replace them with average gender. If you finish it, you go to shoe size, replace them with average shoe size. But if I should put one here, it will fill all the missing value in height, in gender, and in shoe size. It will put 1, 1, 1, 1, 1. Any missing value it sees, it will just put 1 there. Or if I put 0, any missing value it sees, it will just put 0. So that is one way you can handle missing values. So back to our main data set. I just did this duplicate to show you how to fill missing value. So, but most cases, like me, most of the times, especially because if your data set, okay, when will you know when you are to drop and when you are to fill? Now, drop if the number of missing values are not too much. Drop it if the number of missing value are not much. Like in our case, we have 162 data points in total, and we have just a total of let's go back to 4, 6, 8. We have just 8 missing values. It's very small, so you can drop it. But let's assume you have 162 data points and you're having like 50 missing values. Please, in that kind of situation, don't drop. Fill it. Fill the missing value. Because if you drop it, because machine learning needs plenty data to work. As you progress, I'm going to teach you what we call data bootstrapping. Bootstrapping means maybe I give you a data set and the data set is small. With bootstrapping, you can create data set that looks like that data so that you increase the size of your data. Because the larger the size of your data, the better your machine learning work is. The better the model, because the more data you give somebody to train with, the better he understands something. Just like you are teaching a boy, a small child, every day you come to class, you show him this is number 1, this is number 1, this is number 1. A boy that you are showing him number 1 for 1 month and a boy that you are showing him number 1 for 1 week, that person that you are showing him number 1 for 1 month will know number 1 better than that person that you showed him number 1 for 1 week. That one that you showed him number 1 for 1 week, he may know it today, tomorrow he will forget. But a person that you show him number 1 over a month, it will stick to his head. So the more data you give to a machine learning model to learn, the better it becomes. So please, if you have much missing values in your data set, don't drop it, fill it. How do you fill it? I say you call the name of the data, you say .fill now, and then you pass the name of what you want to use to fill. Maybe you say data.min, for instance, then comma, then you say in place equal to 2. When do I say you have to use in place? You have to use in place if you want to automatically update the data set. But if you don't want to use in place, you can remove this in place. And then here, make sure you pass the name of the variable. At the beginning, you pass the name of the variable so that it will go and auto update it. So that is how you use fill now. Now, the second method, I say you can fill it or drop it. Now, in the second method is for you to drop it. How do you drop it? For you to drop any missing value, you say data.drop now. Now means missing value. Data.drop now. So we want to auto update it. So we say in place equal to true. Then we run it. So if you check our data set, data.isNull.sum. Now you see that there are no missing value. So you can see all the missing values are gone. And our data set now has no missing value. So to some extent, the data set is ready for machine learning development. So this is how you handle missing values in your data set. Now, the next thing I did here is also another method. Now, mind you, as we progress, at times I'll be doing data exploration, I'll be doing data pre-processing, I'll go back to data exploration, like I'll be mixing them. It's because data exploration and data pre-processing, they work hand in hand. Because data exploration is the one that will tell you how to do data pre-processing. A typical example, it was when I explored the data, I knew that there are missing values, and then I handled the missing value. So please take note, data exploration, data pre-processing, you can work with them hand in hand or side by side. So I did another data exploration here. Now, the entire data set itself, this entire data set, this thing you are seeing, we call it a data frame actually. But every data frame is a dictionary. Remember, I taught us dictionary last week. Every data frame is a dictionary. So ideally, in the real sense, this data set is being represented like this. It's being represented like this. Height is being represented like this. I'll just give a little illustration behind the scene. This is how the data is being represented. Then each of these column, the first one is 160.0 comma 171.0 comma 174.0 dot 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 till the end. Then after it finished, it separated it with comma, and then it went to the second column, sex no, and then dot, the same way we did 2.0, the same way we're doing dictionary. That is how this data set is being represented. So this data frame is a dictionary. So please take note. Data frame is a dictionary. So if you remember, when I was teaching us dictionary, I told us whenever you want to access the value of a particular dictionary, you call the name of the dictionary and then you pass the key of that dictionary. And then you pass the key. So for instance, if I want to access all the values that are in this height, all I'll just do, I'll call the name of my data set data, and then I'll pass height. If I should run it, you see that all the height will appear. It's because it is a dictionary. You can see all the heights are being outputted. So there is a unique way you can check the unique values, because each column can have unique values. Like this, like height, I will not say height. I know there are unique values, but two or more people can have the same height. Or better still, let's just check it. I'll say data. Another way you can do it is you can just call it like this. Instead of putting data like this, height, which is a dictionary. The difference between dictionary and data set, data frame is data frame, which I said this data is a data frame, is that data frame gives you flexibility. You can access it in form of a dictionary and you can access it outside of a dictionary. So you can either do it like this or you can do it like this. Any one you do, it will give you the same result. Any one you do, it will give you the same result. Any one you do, it will give you the same result. So how do you check the unique values? Unique values means the different values that are in the. A practical example where you will practically and clearly see the illustration of unique values is in this X number. You can see 22222 11111. You can see 2222 repeat 111 repeat. So what are the unique values? Unique values means what are the different values that are in that particular column. So how do we check that? Let's do that for gender rather. Sex no is the name of the column. How do you check it? To check it, you say value count. So value count is used to get the unique values that are in a column. So let's run it. You will see. So you can see it brought out the unique values. Now, why was this one here? This one was here because there was a time I updated this data set here, this place where I did this data too. So because of this thing I did, that was why that gender was added. So let me remove this data too, since I've finished giving an illustration with it. So let me restart my code from beginning. Let me restart it from here. And then let me go to where we removed. And then where we dropped now. Okay. So now let's check our genders. Now, our gender, you can see we have 3 gender in the data set. One was represented with 0, one was represented with 1 was represented with 2. But we have only 2 gender, male and female. And I told you 1 stands for male, 2 stands for female, according to the analysis that the person did. It means this 0 gender that was added was a mistake. Probably, maybe the person didn't put his gender, and then maybe during the data collection, it marked that place as unknown. But because he was trying to process the data, he was trying to label and encode the data, the thing gave it a column 0. Now, the reason why I knew that this 0 is not important is because you see only 2 people have it. So it means there was a mistake there. But if you can check other ones, they have big numbers. So these ones are not mistake because they have real high count. But this one probably can be a mistake. So we have to remove it. It is not important in our data set. And remember, I told you whenever you are removing something, use drop. So how do you remove it? Now, this is how you remove. I created another data set. I call it data1. And I said data1 should be equal to, I'm trying to access before that. Now, let me show you how you can access data based on a condition inside the data set. I want to access this data set, which we call data, right? I want to access the data set, but I only want columns. I only want rows that the gender is 0. I only want rows whose gender, that is sex number, is 0. Those are the only thing I want. So in order for you to do that, what you have to do is inside this data, pass it the condition. So to pass the condition, you always pass the condition inside the bracket. I say first thing, you write the name of the data set and then pass the condition that you want to check inside the bracket. So where do you want to check a condition? We want to check the condition inside the sex column. So we should check the data set where sex column is equal to 0 because we are trying to check this one that has 0. That's what we are trying to check. So let's run it. You see, it will bring us only those columns whose gender are 0. You can see. Can you see? Remember, there are only 2. Their count are 2. So you can see there are 2. These are the only columns that have that gender 0. So from here now, we can remove them. There is no need for us to even pass this. Let me remove this. There's no need for us to even pass through this stress of creating another variable. A very easy way for us to remove it now is we should take note of the index. Remember, I said whenever we want to remove any data that is not important in the role, you use the index. So how do you remove? We will say data dot drop and then we'll pass the list. What is the index of the first one? 110, comma. What is the index of the second one? 128, comma. We specify the axis. This time around, we are removing 2 row, so axis is 0, and then in place equal to true, and then we run. So if you run our data now, you will see that our data set will reduce. The data set will reduce. Let's check our .info, or let's check the shape. You see that the shape that was formerly 112, you can see now it has removed because 153 now. Now remember the total before was 162 and we said we have 8 missing value. So if you remove 8 from 162, the answer is 153. So that is why you can see we have 153 row. Remember I told you in your shape, the first information is the number of row, while the second one is the number of column. So we've removed that gender that is not important. We've removed it from the data set. So that is that on how to remove rows that are not important. So before I proceed to the next thing, another method of data of preprocessing, which we call feature engineering. So before I move to feature engineering, I will give room for questions. Is there anyone with any question? Any question? Are we together? Hello, can you all hear me?
Yeah, we can hear you.
Okay.
We can hear you.
All right. No question, go.
No question
All
from me.
right. So there are some things that I will leave them. We won't do them today because of time, because my target is as most by 10 it should be done. So I will okay. So today we've learned about data exploration, statistical data exploration. I've also learned about how to drop columns that are not important. Now, the next thing is feature engineering. Now, what is feature engineering? Feature engineering has to do with creating new columns from columns that are existing. Feature engineering means creating new columns from columns that are existing. So, I did one simple feature engineering here to show us an instance. And the name of the column, I call it size per height. I just formed it to just show you how feature engineering is being done. The name of the column is size per height. Now, what is size per height? Size per height is a column that per means you divide something. So size per height from my calculation, I gave it a formula. Size per height, size per height should be equal to um the height of a person divided by his shoe size. Okay, sorry. It's supposed to be shoe size divided by the height of a person. That is the formula for this size per height. That is the formula. So, coming or let's leave it like that. Let's leave it. Let me change it. Let it be height per size rather. Height per size. So now this is the formula that I give to get this height per size. So I want to add this column to my data set. It's not there. I want to add it. So how do you add column to a data set? The same way you add data to dictionary. You write data, that's the name of the data set, and then you pass the key. And since I said height per size, that is my key for this work, height per size. So I put the height per size in quotation mark, and then we said equal to. So what should be the value that it should calculate is just this formula given to you here. We said in order for it to get the height per size should be equal to all the height that is for each row. You should divide the height by the shoe size. For each row, divide the height by the shoe size. And how do you assess the height of a data set? You say data in quotation mark height, because if you just write height, it will raise an error for it. There is nothing like height. But if you say data and then height and run it, data per height and run it, if you say data per height and run it, you see it will bring out an output for you. Aha. So this height per size is what the way it works is going to divide this height by this shoe size. Divide this height by this shoe size. Once it finish for the first one, it will do for the second one. Once it finish, it will do for the third one. Once it finish, it will do the fourth one. Like that till it finishes. So in order for you to access that, remember to access your height is going to be data and then height like this. And for you to access your shoe size, it's also the same thing. You say data, shoe size. So that is why I'm trying to implement this formula here. I try to implement the formula here, but before implementing that, I have to individually access each column. So that is why I say data height, then followed by the division size here, division sign. This is the division sign, and then data, and then my shoe size. So I passed it, and then the moment I run this place, now when I run my data, now you will see that a new column has been created. You can see formerly it was 3, now another column has been added. So that is what we call feature engineering. So that is what we call feature engineering, where you add a new column to your data set. So with that, I think I will stop here for today. So attached to this file, the other things we'll do it in the next class, which is on Sunday. We'll do that in the next class. However, I'm going to give you a data set, and then let me edit some parts of the assignment. Or better still, yeah, let me just edit. Okay, better still, I'll send you the assignment file separate. It's this same thing, but I'll just do some editing. I'll just do some editing because we didn't finish everything within the file. Else, we would have do everything that is here. So I'm going to send you the data set and also the briefing of the assignment so that you can attempt it before on Sunday. It's just one question and it will just be basically all the things we discussed, nothing new. So you just practice it and see the application of what we've learned so far. So I don't know. Is there any question? We've come to the end of today's class. So if you have a question, you can ask. Anyone with any question? Hello, are we together?
We can hear you. I
I
don't
said
know.
I've come to the end. Is there anyone with any question?
Okay, yeah, that is me. If I'm waiting to see if there's anyone that has question because I don't also have any question to ask.
But the explanations are clear, right?
Yeah, yeah,
Okay.
it's clear.
So
Yes.
I think there's no one with any question. Okay. Is there any question? For those of us that
Okay,
are unmuted,
I just have something.
okay.
Okay, I just have something though out of the class,
Okay.
but still concerning out of is out of this class, but still concerning the course.
Okay.
Yeah.
Okay.
Like all those files now that we're
Yes.
working on,
Yes.
hmm,
Yeah.
that we normally import before starting
Yes.
the class
Yes.
each day. I don't know how do one come about those files.
Okay. 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 That's a quick question. Now, you can see this my Google Colab environment, right?
Yeah.
So to do that, once, okay, let me come out of it. So if you go to your Google Colab, I will show you how to do it here and also how to do it on VS Code. So once you now remember in the Google Colab, whenever we open, the first thing I tell you is to upload, right? Now, if you want to create a
Mm,
new one, you don't upload, you just click on new notebook. That is all.
okay.
So it will load up. So you can see, yes, this is where you change the name of the file. Maybe I can say UC work, name of my file,
Okay.
and then I can start my writing import pandas as PD. And then let's assume I finished doing all my code. Okay, it's connected. I finished doing all my code. Now this online one it automatically saves to your Google Drive. It auto saves to your Google Drive. So once you are done, and then maybe you want to access it in your system, you go to this file
Mm,
and then go to download, and then click on. Don't download this .py. Download this one. Download .ipyn, and then you save it where you want to save it. So I saved it to my desktop. Now if I come to my desktop, this is the file here. Click it and open. So that is how I usually do it and then send it to you guys. So you can see.
okay.
So this is the file. So that is how you can do it on Google Colab.
Okay.
Okay, what if sorry, let me show you how to do it on VS Code. What if you want to do it on VS Code? To do on VS Code, you click on file, you click on new file. Sorry, you click on file, you click on new file. Look at it. Jupyter notebook.
Mm,
This one, you click it. You can see here you can write your import pandas as PD. And then you save. To save it, you click on file, you click on maybe save or save as anything. Then you go to the folder that you want to save it. You can say JC
Okay.
work 2 and then save. That's all. So the difference is that this one you don't need to download because you are saving it to your local machine. But the one on Google Colab is
The
you
web.
down
Mm,
you write it and it's saved to your Google Drive, so you need to download it to your local machine. So it's clever.
okay. Yeah.
All right. So um, any other question, Mr. Isa? I thought before you unmuted your mic, you wanted to ask me.
Oh, I'm just greeting you, sir.
All right. Thank you, sir. Mr.